Advanced Spiral Techniques. This is the first in a series of instructional videotapes designed to help you get the most out of your woodchuck 5-axis milling system. In this video we will demonstrate several techniques for milling a variety of spirals. In other videos we will cover subjects including advanced indexing techniques, router bits, and much more. Let's start by quickly going over the system's features and controls. In this video we will be working on the model MA12-33 with the motor drive upgrade and the optional gear reduction sets. These items can be purchased with the system or added only as you need them. Let's begin now by looking at the system's basic operations. If you apply a light coat of paste wax to the rails and carrier tray, the system will operate smoothly with very little effort. The XY table allows you to move the router 4 inches off-center in the Y-axis. The stops can be opened up to mill up to an 8-inch flat or set to hold the router centered for milling index cuts or spirals. The router can also be connected to the drive screw for positioning or power milling. Note the Y-axis positioning screw is optional on the model MA10. The carrier tray can be positioned anywhere along the rails in the X-axis. It can be moved manually or connected to the X-axis drive screw for power milling, positioning, or milling spirals. You can adjust each end of the bed independently, lowering the bed to accommodate large diameter stock and raising it for a workpiece with a smaller diameter. Setting the bed on an angle will allow you to mill a tapered section in either direction. Note the elevation screws are optional for the MA10. The indexing headstock allows you to mill multi-sided cross sections, indexed accent cuts, or multiple starts when milling spirals. Now let's talk about the features that make it possible to create the various types of spirals illustrated in this video. The pitch is defined as the distance the router travels for one complete rotation of the workpiece. The system comes standard with 5 drive gears. These produce pitches measuring 3, 4, 5, 6, and 7.5 inches per rotation. Changing the gear reduction set to one of the optional sets will either reduce or expand these 5 standard pitches, making a total of 20 pitches ranging from 3/4 of an inch to 15 inches per revolution. The pitch you choose will depend upon the style and type of spirals you want to mill. Let's do a quick overview of the spiral drive, its components, and the setup procedure. Place the pivot arm assembly on the 2 shafts after applying a little grease. Place the index gear on the index shaft. Next, place the gear reduction assembly onto the pivot arm assembly. Engage these gears and lock in place using the T-handle Allen wrench provided with your system. Place a 45-tooth drive gear, followed by a flange washer, the desired drive gear, the second large flange washer, the spiral handle, and secure them in place. As you rotate the spiral handle, the drive screw will move the router as the gear reduction rotates the workpiece. Here are some of the custom designed bits and standard router bits we used in this video. The type of bits you use will depend upon the style you want to create. To mill the stock round, we start with a 2-flute straight cutter and offset the router to the far side approximately 1/8 of an inch. We used the 0.25 times gear reduction set and the 60-tooth drive gear to produce a 3/4 inch pitch. The 1 1/4 inch diameter bit overlaps to remove all of the stock in a single pass. To mill the finished surface, we change to a 1 1/2 inch diameter surface planer bit and offset the router to the near side approximately 1/8 of an inch. This will produce a smooth surface requiring very little sanding. Milling a spiral flute on a spindle or post is completely free-form. There are no real guidelines to follow. The bit is typically a core box or round nose bit. However, changing the profile of the bit can change the piece from ordinary to extraordinary. We use 2 Jorgensen clamps for the starting and stopping positions for the flutes. To avoid burning at the start of each flute, plunge the router a little before the end point and mill to the stop. Then reverse the direction to complete the flute. In this example, we will mill a spiral flute with 12 starts using the 12-inch pitch. To obtain this pitch, we use the 2 times gear reduction set and the 36-tooth drive gear. The woodchuck indexing system makes it quick and easy to mill indexed flutes, even on a spiral. After milling to the stop, back the router up slightly until the index pin aligns with one of the holes. Then disengage the gears and rotate to the next desired hole. Use the index pin to lock the workpiece in place while you re-engage the drive gears. From the end view, it looks like this. Mill to the stops, and then raise the bit out of the workpiece. Back up the router until it aligns with a hole. Disengage the gears and rotate the workpiece to the next hole. Re-engage the gears and remove the indexing pin. You will repeat this process for as many flutes as desired. Be sure to disengage the index pin and lock it in place before attempting to mill the next flute. To end each flute, mill to the stop and then back up slightly to avoid burning the workpiece. To get the most out of your system, spend some time experimenting. Try combining different bits, pitches, and number of flutes. Who knows, you may create a unique style. On the other hand, you may end up with some very ornate firewood, so use something inexpensive. Now let's take a quick look at the optional motor drive and its features. The hand control allows you to move around the machine while controlling the speed and the direction of the router carrier. One of the biggest advantages of the motor is the convenience and freedom of movement when operating the machine. The smooth feed rate and constant torque of the motor results in a superior cut. The motor upgrade comes with the hand control, variable speed DC motor, and snap action limit switches. To override the switches, you simply reverse the direction and push the override button. The speed can then be set anywhere between 0 and 102 rotations per minute for the optimum cutting speed. switches can be positioned anywhere along the top rails to limit the length of the flute or the area to be milled. For our next example, we will use the optional number 2 Morris taper index shaft and a standard lathe type drive center. This option makes it easy to mill secondary operations on parts turned on a production lathe. It is also very popular with custom wood turners. Here we will mill spiral flutes following a contoured surface. The stops are set to allow the router to float. For this operation, we use a side cutting flute assembly with bearings above and below the cutter, with the bit set at the center of the workpiece. Simply slide the router into the work until the bearings contact the work surface and start the motor drive. In this example, we use the 2x gear reduction set and the 24-tooth drive gear for a 15-inch pitch. To create a 4-start spiral, we index to every third hole. Now simply repeat this process 4 times to complete the spindle. Again, you can combine different bits, pitches, and number of starts to mill a variety of flutes or beads. Is this cool or what? Next, we will mill a traditional 4-start rope spiral. These starts are spaced 1 inch apart. Therefore, we will use the standard gear reduction set and the 45-tooth drive gear to produce a 4-inch pitch. With this style, we use a point-cutting roundover bit. This bit uses a full quadrant, so the cutting depth equals the radius of the bit. This produces a very pronounced bead. These bits are stock items up to 1 inch diameter. Larger diameters must be custom ground. With this particular style, you want to keep the pitch approximately 2 times the diameter of the workpiece. For example, this 2-inch diameter workpiece requires a 4-inch pitch. Now by dividing the pitch, which is 4, by the number of starts, also 4, we can calculate the bit diameter to be 1 inch. Therefore, we can use a stock bit. Again, the quickest and easiest way to mill 4 starts is to simply remove the workpiece and rotate it 90 degrees. Depending upon the wood you are working with, you may need to make multiple passes to complete each bead. If you want to keep the beads approximately the same size, you can simply add more starts as the diameter gets larger. For example, a 6-inch diameter workpiece with 6 starts would also use the same bit. The most common styles of rope molding have either 3 or 4 starts. However, you can have any number of starts, and the bit profiles can change to create the effect that you want. In this next example, we use a custom ground 3-inch diameter router bit to mill a single start barley twist. We use the standard gear reduction set and the 60-tooth drive gear to produce a 3-inch pitch. Generally, the router bit diameter will be equal to the pitch. We chose a pitch of 3 inches, which is slightly larger than the diameter of the workpiece. This will vary depending upon the style you want to create. Again, to change the pitch, you simply disengage the gears, then remove the handle, the large flange washer, and the drive gear, and replace it with the desired gear. Then replace the flange washer, the handle, and re-engage the gears. The technique to mill this profile is very simple. It is a single start, but because of the size of the cutter, we made 3 passes to complete the process. Because we were milling off the entire surface, we did not need to make a cleanup pass on the stock surface. After completing the first pass, simply plunge to the next depth and reverse the direction. This is a very elegant design that will add a touch of class to your next project. To set up for the 4-start hollow spiral, we will change to the 2x gear reduction set and the 36-tooth drive gear to create a 12-inch pitch. We will also change the direction of the spiral by engaging the reverse drive assembly. To reverse the direction, start by engaging the reversing gears. And then you'll move the spacer from the reversing shaft to the drive shaft. Next, put on the flange washer, the desired drive gear, the second flange washer, and the handle on the reversing shaft. Then loosen the cap screw to rotate the reverse drive assembly as far as possible towards the pivot gear, and then engage these gears. The best bit to use for this technique is the 2-flute spiral cutting bit. It will lift the chips up out of the groove as it moves. However, you can also use a 2-flute straight cutter, which is a whole lot less expensive. We start by milling 4 pilot holes halfway through the material to begin each start. We can then plunge down approximately 3/4 of an inch to make the first pass. Several passes may be necessary depending upon the diameter of your workpiece and the diameter of your router bit. Again, we rotate the workpiece 90 degrees to create a 4-start hollow spiral. To create a unique effect, we glued up several blocks of maple and alternated the direction of the grain. To create a hollow spiral, you need to make at least 2 starts that meet in the middle. However, you can mill as many starts as the diameter of your workpiece will allow. Just remember that the longer the pitch, the stronger the piece will be. To mill a diamond pattern, you need to make the pitch approximately 3 to 3.5 times the diameter of the workpiece. The greater the number of starts, the tighter this pattern will be. We will use a simple V-groove bit to mill the flutes. However, you may want to try other profiles to change the effect. To begin, simply plunge down to the desired depth and make the first pass. The diameter of this workpiece was 2 7/8 inches. If you multiply 2.875 times 3.5, you will get slightly over 10 inches for the pitch. Therefore, we used the 2 times gear reduction set and the 36-tooth drive gear to produce the 10-inch pitch. Again, we simply used 4 starts so that we could quickly rotate the work 90 degrees on the index hub to begin the next flute. You can mill up to 12 starts to create a very tight pattern. After repeating the milling process for all 4 flutes, you need to change the direction of the drive as shown earlier in this video. Only this time, we will move the drive gears from the reversing shaft back to the drive shaft. Notice that we have replaced the handle with the second drive gear. This simply makes it so the handle is not swinging around and getting in the way when using the motor drive. Start the next series of flutes in the same position that the opposite set ended. Again, we will mill 4 starts to complete the part. Because we use a high-speed cutter, the surfaces and accent cuts are very clean and smooth, requiring very little touch-up sanding. Notice how the pattern stays in proportion as you change the diameter of the workpiece, as long as you make the pitch 3 to 3.5 times the diameter. To create the large screw effect, we use the same V-groove router bit, but change the pitch to 3/4 of an inch per rotation by setting up the 0.25 gear reduction set and the 60-tooth drive gear. This is a single start technique that can usually be milled in just one pass. Again, by changing the router bit profile, you can dramatically change the effect. For our next project, we used a 2.2-inch diameter custom bit. This bit was originally designed to reproduce an antique chair with hand-carved spirals. We will be using it to create a different effect. We have set up the system with the standard gear reduction set and the 60-tooth drive gear to produce a 3-inch pitch. Because the bit diameter is only 2.2 inches, this will leave a 0.8-inch flat between each pass. We made 3 passes to cut the full depth of the router bit. As we reach the end of the cut, we simply reset the router to the next plunge depth and reverse the direction. After this cut is complete, we remove the workpiece and rotate it at 180 degrees to start the second cut. Now we change to a 3/4 inch diameter point cutting roundover bit. This second cut will be exactly in the center of the 0.8-inch flat created by the 3-inch pitch. By combining different router bit profiles, you can create a wide variety of stunning effects. This video is just a small sample of spiral components that your woodchuck 5-axis milling system can produce. In our next video, we will demonstrate the powerful indexing and milling capabilities of the system. We will demonstrate precision joinery, such as radial mortising and slotted dovetails, as well as beading, fluting, tapering, and milling multi-sided cross-sections. Combine all of these powerful features in your imagination to create a competitive edge. You are really limited only by your imagination.